So now the fourth one, what we have is, it's given by integration of dx divided by square root of x square minus a square. Now this one, the formula of this one is log of x plus root over of x square minus a square plus c. So you have to remember these formulas. And then we have another one, that is, which is quite similar to this one, integration of dx divided by root over of x square plus a square, that is given by log of x plus root over of x square plus a square plus c. So you see these two are quite similar. So previously we had these two similar, and then we are having these two quite similar, right? Now the last one what we have is, the last one is integration of dx divided by root over of a square minus x square. This gives us sine inverse x by a plus c. So basically these 6 formulas you have to remember in order to solve the problems of some special particular functions. So basically the forms you have to remember. So one thing you see, these two are kind of related, where we have x square minus a square and we have a square minus x square. Then we have two other forms, that is root over of x square minus a square and root over of x square plus a square. They are also related, right? And the last one, that is integration of dx divided by root over of a square minus x square, and that gives us what? Sine inverse x by a plus c, right? So like this way, this 6 forms you have to memorize, right? Now after remembering these 6 formulas, how we should start with the problems, how we will start solving with the problems. So suppose we start with exercise 7.4. yeah. So how we are going to solve the problems? So basically let's start showing one question. So first question we have is that we have to integrate, they have given a integrate 3x square divided by 1 plus x to the power 6. So we have to integrate this thing, or we can write this one as, okay, it will be x to the power 6 plus 1. It will be x to the power 6 plus 1. Basically we have to integrate this thing, or else we can write this one as I is equal to integration of 3x square x to the power 6 plus 1 dx. So we have to integrate this. Now first thing, my main motive is to do what? Is to try to think of, is to look at the problem, this function, and try to think of that this problem is closer to which one of them. It's x to the power 6. Now when you look at these 6 formulas, we have x square in here, x square in here, then root over of x square in there, but here it's x to the power 6. So how can we relate with those 6 formulas? So we cannot. So what we are going to do is, first thing we are going to do is, we see the numerator, there is 3x square, right? And x to the power 6, we can manipulate it and we can write this one as 3x square. We can write x cube whole square plus 1 dx. Why? Because I know the differentiation of x cube gives us 3x square. So I'm writing x to the power 6 as x cube whole square. Okay. Now once I write this thing, then what we will do is we will substitute x cube is equal to t. So I will write here, let x cube is equal to t. So differentiating with respect to x. So if I differentiate with respect to x, what do you get? We have 3x square, and this side we have dt dx, right? So we have to find dx. Therefore dx will be given by dt divided by 3x square. This is what we have, right? So let's put this substitution in the above problem and see what you get. So my I will become what? So I will become I is equal to integration of this numerator, there is 3x square. So I will write 3x square in there. And in place of, here we have x cube. So I will write it as t square plus 1. And in place of dx, I will write dt by 3x square. So what we have is this 3x square goes out. So we have integration of dt divided by 1 plus t square. Now you try to see this one as dt by 1 plus t square. Now this one looks similar to which one of them? It doesn't look similar to the first one because it is x square minus a square, but here it is what? 1 plus t square. So think of it as 1 plus x square. A square minus x square, there is a minus sign, no. Now you look at this one. It is what? X square minus a square. So I will just think of, here the variable of integration is what? X. But here the variable of integration is t. So, and x square plus a square. So basically it is what? T square plus 1 square. We can think of it like that. T square plus 1 square. So we have dt divided by t square plus 1 square. So where a value is equal to what? My a value is 1. So I will write this form. The formula will become what? It is what? 1 by a. So I have 1 by 1. Tan inverse. In place of x, I will write the variable. The variable of integration in here is t. So it will be tan inverse t by 1. So basically we are getting tan inverse t plus c. So what we are getting in here? So we are getting tan inverse t plus c. And where t is what? T is x cube. So I will write here tan inverse x cube plus c. So that's how we find the answer. So all we have to do is we have to manipulate the problem into something closer to these 6 formulas. And once we get something closer to these 6 formulas, we can directly write the integration formula which we have for the 6 different special functions. Okay. Now let's try to do question number 2. So question number 2, what we have is integration of, now we have to integrate. So I am directly writing this one. So I is equal to integration of 1 divided by root over of 1 plus 4x square dx. So we have to integrate this one. So what we are going to do is we have to try to think this one similar to these 6 formulas we have. So basically the question was what? 1 divided by root over of 1 plus 4x square. Now this looks similar to which one of them? Basically 1 plus 4x square, I can write this one as 1 divided by root over of 1 plus 2x whole square. So it is what? A square plus x square, root over of a square plus x square. It is similar to a square plus x square. And where is it? Root over of a square plus x square? Here it is. So it is quite similar to this one, right? So I will try to manipulate that one into this formula number 5. Let's try to do that. So we are going to write here, let's write this one as let 1 divided by root over of 1 plus 2x whole square dx. Then we are going to write let 2x is equal to t. So I will assume 2x as t. Then we will differentiate both sides with respect to x, differentiating with respect to x. So what you get? This one is 2 and this one you are getting dt dx. So dx is equal to what? Therefore dx is equal to dt by 2, right? So now what will my I become after this substitution? My I will become 1 by root over of 1 plus, in place of tx I will write 2, and in place of dx I will write dt by 2. So this 2 I will just take it out, and we have integration of 1 by root over of t square plus 1 dt. So this, this one will be dt. Now this looks similar to what? X square plus a square, 1 by root over of x square plus a square. And what is the formula? 1 by root over of x square plus a square. The formula of this one is what? Log of x plus root over of x square plus a square. But we have what? 1 by root over of t square plus 1. So the formula of this one will be what? Where x is t and a is 1. So it will be log of t plus root over of t square plus 1 plus c. That one will be the formula. So we have what? This one will be half log of t plus root over of t square plus 1 plus c. So now in place of t, what are you going to write? 2x. So half of log 2x plus root over of t square is what? 4x square. That's my answer. Okay. Now question number 3. So in question number 3, it's simply similar to question number 2 only. So in question number 3, you just substitute 2 minus x is equal to t, and then you will get the expression similar to root over of t square plus 1, and that is similar to the formula of this one, that is root over of x square plus a square. The same thing, question number 3 is same as question number 2. Now let's try to do question number 4. So question number 4, what we have is it is also similar, but let's do it. So we have to integrate 1 divided by root over of 9 minus 25x square. So what we are going to do is, we are going to write this one as integration of 1 divided by root over of, in place of 9 we can write 3 square, and in place of 25x we can write 5x whole square. We can write this thing. Now if you look at this one, this looks similar to square root of a square minus x square. It looks similar to this one, square root of a square minus x square, right? So here it is 5x, so I will substitute 5x is equal to t. So I will write here, let 5x is equal to t. Then what do we have differentiating with respect to x? What do you get here? 5 is equal to dt dx, and what you get in here is, therefore dx is equal to dt by 5. This is what you have. Now let's substitute. So what do we have? I is equal to integration of 1, we have forgot to write dx in here, dx. So I is equal to root over 1 by root over of a root over of 3 square minus, in place of 5x I am writing t, so we have t square, and in place of dt dx I will write dt by 5. So 1 by 5 taken out, integration of 1 divided by root over of 3 square minus t square dt. So what is this? So here we have what? We know the integration of 1 by a square minus x square. This integration we know, and that is what? Sine inverse x by a plus c, right? But here is what? 3 square minus t square. So it will be what? 1 by 5 sine inverse, in place of x I will write t, sine t, and in place of a I will write 3 plus c is equal to 1 by 5 sine inverse, in place of t, what I am going to write? 5x by 3 plus c. That's what we are going to write. Okay, clear? Now let's do question number, question number 5 is quite similar. So in question number 5, I will just tell you the form what we get, then you proceed with question number 5. So question number 5 is what? 3x divided by 1 plus 2x to the power 4 integration of dx. Now we have to integrate this one. So what we are going to write is, we can write this one as 3x divided by 1 plus, it is 2x to the power 4. We can write this one as root 2 x square whole square dx. We can write this thing. Now you see that differentiation of x square is what? 2x. So here this x numerator, there we have x. So we can substitute root 2x as root 2x square as t. So once you substitute that thing, this x in the numerator will go away. So what we have, right? Let root 2x square is equal to t. So differentiating with respect to x, what you get is root 2 root 2x, because differentiation of x square is 2x, is equal to dt dx. This is what we have. So from here, what is dx? So therefore dx is equal to dt divided by 2 root 2x. This is what we have, right? Now after this, what we are going to do is, now we have to write I. So I will become what? Integration of 3x divided by It is 1 plus 2x root 2x square. So 1 plus, in place of root 2x square I will write t, 1 plus t square, and in place of dx I will write dt divided by 2 root 2x. So you see this x and this x gets cancelled, right? So what we are left with, 3 by 2 root 2 is constant. So I will just take it out, 3 by 2 root 2, and then we have dt divided by 1 plus t square. And you see this one, dt divided by 1 plus t square, it's quite similar to integration of dx divided by x square plus a square, or a square plus x square. And the integration of this thing is 1 by a tan inverse x by a plus c. That's the integration formula. If you look at here, integration of dx x square plus a square, this is the formula. So what we have, in place of x I will write t, and in place of a I will write 1. So what we have is 1 by 2 root 2 tan inverse, that's a 1 by 1, a is 1, right? So I don't need to write 1 by 1. So tan inverse t by 1. So again I will write t plus c. You know that integration of 1 by 1 plus integration of 1 by x 1 plus x square is what? Tan inverse x, right? Integration of 1 by 1 plus x square is what? Tan inverse x. So here integration of 1 by 1 plus t square is tan inverse t. Simple as that. So we have 3 by 2 root 2, and in place of t what we are going to write? Root 2x square. So we have tan inverse root 2x square plus c. That's my answer. That's how we do it. Okay, now question number 6 is quite similar. What I will do is, it's quite similar to question number 1. So I will take x cube whole square. In place of x to the 6 I will write x cube whole square. Then I will substitute x cube is equal to t. Then that numerator x square will go away. Okay. Acha. Now if I look into question number 7, then let's try to do question number 7. How we are going to do question number 7? So question number 7 is what? We have to integrate x minus 1 divided by root over of x square minus 1 dx. Now if I differentiate, now look at carefully, if I try to differentiate the denominator, that is x square minus 1, we get only 2x. So we get only one term. But in the numerator there is two terms, that is, one is x, then there is minus 1 in there. So what we are going to do is, we try to separate them. And how we are separating? I will write this one as x divided by root over of x square minus 1 dx, then minus 1 divided by root over of x square minus 1 dx. So once we separate this one, now my idea becomes very, very clear. What is that? Now you see, this one we can easily solve by method of substitution, which we have solved in previous question. So I will substitute x square minus 1 is equal to t square, because there is square root in there. So I am substituting x square minus 1 is equal to t square. So this one can be easily solved. And this one, you can easily solve this one also. Why? Because this one is similar to the formula. This is quite similar to this formula, where a is 1, right? So what was the formula of this one? The formula of this one was log of x plus root over of x square minus a square plus c, right? So what we are going to do is, I will write this one as I1. So what I am going to do, I will write this one as I1, and I will directly do the integration of this thing. So I will write this one as log of x plus root over of x square minus 1 plus c. Let's write this one as c1 or c2, because it's not the entire constant, because I1 we haven't done. So let's find out I1. So what will be I1? So I1 is equal to integration of x by root over of x square minus 1 dx. Now we'll substitute x square minus 1 is equal to t square. So let x square minus 1 is equal to t square. And why we are substituting this thing? Because the differentiation of, because there is a square root, so we are substituting t square. So now what we get, differentiation of x square minus 1 is, it is 2x, and differentiation of t square is what? 2t dt dx. So this 2 gets cancelled. So therefore dx is given by t by x dt. Now let's substitute. So if I substitute, I1 will become what? It will become integration of x divided by, now square root of x square minus 1. So we have square root of t square into, in place of dx we are going to write t by x dt. So let's see what getting cancelled. So x and x gets cancelled. Now square root of t square is only t, so this also gets cancelled. So we are having integration of this thing, and that is what? T plus c. And what is t? T is nothing but x square minus 1 is equal to t square. So t is square root of x square minus 1 plus c. Let's write c1 in here. c1. So therefore at the end I will be equal to what? I1, that is root over of, you just look into here now, x square minus 1 minus log of x plus root over of x square minus 1 plus c. Now you can write c because you have done the entire integration.